Okay, guys, with the other spinner problems that we had done before this one, the idea was basically this. We want to have an equally likely outcome or an equally likely chance that anything could happen. So when I spin the spinner, get this bad boy spinning around, where's it going to stop? Well, again, there was always an even chance that any particular space on the wheel could actually be hit. If you look at some of these right here, however, it no longer turns out that way. So, for instance, this pipe piece right here has a 45-degree angle. This is a 45-degree angle. Now we're different. Now it's 90 degrees, 10 degrees, 100 degrees, and 70 degrees. A couple things we need to keep in mind. We're still going to do basically the same idea as far as setting up a probability. So if you recall, the fraction that we use is favorable over possible. But now the possible is going to be the same every single time. Here's the idea. All of these guys right here in the blue, what are they called? Well, because they got a degree measure right there, those are the angle measures. So the total possible angle measure that we have in any particular circle is always going to be 360 degrees. So guess what? Every one of these problems right here, when we begin, is going to look like this, something over 360. Now all we have to do is identify how much the angle measure is for whatever pipe piece we're talking about. Here we go. Let's take a look at number one, and let's see if we can't get things a little bit straighter with some examples right here. So what is the probability of spinning 500? First off, again, we're going to set up our fraction right here that is probability. Favorable over possible. The easy thing to write is the possible. And again, how many degrees exist in all circles, or the measurement all the way around the middle of the circle? It's 360. So on the bottom is going 360. Now we're looking right here for spinning at 500. Where's 500? 500 is right here. How large is that angle? That angle is only 10. Or 10 degrees, I should say. So there's my probability. I'm done with that right there. It's 10 over 36. I say I'm done with the setup. You got to take one step further. You have to actually simplify. So divide the top and the bottom by 10. And we end up with a probability of 1 out of 36. And again, what does that mean? If I spin the wheel 36 times, the probability of me hitting a 500 is 1 time out of 36. If I move on to the next one, let's try to put it together again. What's the probability of spinning $300 or greater? Again, setting up the probability right here from my fraction, the words, favorable over possible. Well, the possible, again, is the angle measure all the way around the circle, which is 360. And now where is 300 or greater? This one's going to be a little bit different. And here's why. 300 or greater. Start right here. Is 400 greater than 300? I say yes. What's the angle measure? 45. Plus sign. 300. Is 300 even or greater? Yeah, it is. So what's the angle measure there? Another 45. Keep on coming. 100 is not greater than 300. 500 is, so we have to add 10 degrees. And keep on coming. 50 and 200 obviously are not greater than 300, so I'm done with the setup and the structure of the problem. Now all we have to do is add what we see in the numerator, 45 plus 45 plus 10, and you'll end up with 100. Nothing changes in the denominator. It stays 360. So again, how did all this come from? All the possible choices that I had of being 300 or greater, I have to account for them all. So a 400, a 300, and a 500 are all greater than 300. And so I need to write down what is the degree measures of that particular pipe piece, so to speak. Last thing I need to do is I need to reduce this fraction right here. So actually, if you divide the top and the bottom by 20, the greatest common factor, you should end up with 5 over 18. So that's the simplified version of that one right there. And now the last one that we have, what's the probability of spinning 200? Well, that one right there again. Set up your fraction with the words that we have favorable over possible. The possible is always going to be 360. How many places is 200 in there? It's only written or expressed one time. There's only one place on the wheel that's 200. And what's the degree measure there? 70. That's as far as we can take that particular problem. The last thing that we have to do, though, is we have to reduce the fraction. So divide the top and the bottom by 10. and the result is 7 out of 36. So again, if you spun this spinner 36 times, the probability of you hitting $200 would be 7 times out of 36 times. And again, that's just a prediction. It doesn't always mean that it's going to work out that way. All right, take a deep breath and get yourself ready to go. This one right here has got a couple of twists to it. What is the probability of spinning a sum of $200 on 2 spins? So keep in mind now we're talking about multiple events taking place. The 2 events that are taking place is the 2 spins. So what we need to do is there's going to be a little bit of multiplication, there's going to be a little bit of addition. So the first thing I want to do is I want to identify how can we get a sum of $200. Well, based on the information or based on the dollar amounts that are on our wheel right here, the only way to make $200 on 2 spins would be to do A, $200 plus $0, that would give me $200 bucks. Or I could spend $0 on the first spin and $200 on the second spin. That could happen. And the last option that I have would be to spend $100 on the first spin and $100 on the second spin. So now really all we need to do is we need to set up the probabilities that exist with each of these particular events that are taking place. So how are we going to do the 200 plus 0? Well, set up the one probability that we have right here. What's the probability of me hitting $200? The probability of hitting $200 would be 70 over 360. And if you recall from the video previous this one, when I have 2 events going on at the same time, I'm going to multiply those together. What's the probability of getting $0? That's a bigger one. 100 degrees out of 360. Now what we're going to do is we're going to add these together. What's the probability of hitting a 0 on this particular spinner? We've already found that. It's 100 over 360. And multiply times the probability of getting 200 on this particular spinner. We found that to be 70 over 360. And that's the end of that one. Last one will be different. Got different number of values on this particular wheel. The probability of hitting 100 on this wheel. Look up here. What do we got? The probability of this one is 90 over what? Hopefully you're saying 360. That's not going to change anytime that I have a circle, right? The total degrees around the center of the circle is going to be 360 degrees. Now I need to hit 100 again, so that's not going to change there. Multiplying it times itself. Okay, so the setup of our problem is now complete. Here's what you can do. No doubt about it. You can do this. You could multiply the tops times each other and the bottoms times each other and do this with these gigantic numbers right here. And in the end, you're going to have a really, really big fraction. And then you'd have to reduce with numbers that are sometimes a lot more than you want to handle. Something else that you could do is you could find a way to reduce the fractions that are existing here, reduce these guys already. Now I'm dealing with smaller numbers. If you'll notice, every one of the numbers that we have up here, all of them end in a what? They all end with a 0. We can divide everything by 10, which means just get rid of the last 0. So my new setup is going to look like this. Already the number is getting smaller and a lot easier to handle. Now some of you will notice that there are ways that I could reduce these numbers even more, and that's fine. However, but by doing that, I'm going to change the denominators, and because we're adding fractions in the end, I want that denominator to be the same all the way through. Now if we go through the process of multiplying, right, I'm just order of operations right here, so working inside each set of parentheses. And remember, how is this happening? I'm multiplying across the top, multiply across the top, multiply across the bottom, and that extends to there. This one's exactly the same, just the order has changed. And the last one we end with, 81 over 1296. Now because I'm adding fractions, I have to have a common denominator. We've already taken care of that. The number on the bottom of every one of these is the same, so I don't have to change that. All I have to do is add the numerators together. When we add the numerators together, you will end up with 221 over 1296. So again, that's kind of a funky number right there, and it's hard to understand exactly what's taking place. But roughly what it's saying, that if I spin this spinner right here 1,296 times, how many times would I get a sum of $200? Well, normally it would turn out to be about 221 times. Now again, is that always going to hold true? No, it's a prediction of what should happen if you spun this thing 1,000,000 times or so. So there we are in the end with a pretty difficult problem. If I was you, I would watch this maybe one more time just to see it all taking place for you once more. The more times you do this, the better off you'll be.